going to be showing us how we can get started building decentralized web applications using the Web5 SDK. We're going to be showing similarities and differences between how we currently build for the web and how it works in a decentralized web. To achieve this, we are going to be building a basic Todo app and showing you some of the decentralized features of the Web5 SDK. This tutorial is already available on the documentation, and you can find it on the apps here, so you can learn how to build a Todo app. Let's get right into it. So to avoid starting from scratch, I have a copy of the startup templates that we have for this Todo app. We are currently using Vue and Next.js to build out this example. So if you're working with React or Next.js, the core principles still stay the same, except the parts that are just, framework specific. To see a preview of what we currently have, I'm going to run npm run dev and open that up in the browser. This is our current website, just basically a to-do list. Nothing special is written there at the moment. This is what our final app is going to look like, where we are able to create a new to-do and stored in our data storage. If you're building a to-do app today, we would want the users to sign in using either their email address and password, or maybe a third-party plugin like signing with Twitter or GitHub, right? And also, if we want to store the to-dos that they're adding to their application, this will most likely happen either storing it in local storage, or storing it in database, or even sending it over an API, depending on how big or complex the to-do app is. For this example, we are building something quite basic, and it will involve us using just 2 out of the 3 major pillars of Web5, which is building with decentralized identifiers and the decentralized web nodes. The DIDs, which are decentralized identifiers, will be replacing current authentication flow, while the decentralized web nodes will be replacing any database or API request we are going to be making. The first thing we want to do is install the Web5 SDK. And we can do this by doing npm install web5/API. Once this is done, all we have to do is check our package.json and ensure that we have our type set to module. So now let's initialize Web5 in our app. We head over to app.view and we import Web5 from Web5 API. Now we need to initiate instances that we can use to store our Web5 instance and also store our decentralized identifier, so DID. We also want to be able to track our to-dos at the end of the day, so we're going to set a reactive variable that houses the arrays of to-dos. The Web5 variable will eventually hold our Web5 instance from the SDK, and the user DID would be the decentralized identifier of any user that is using this application. So our next step is to both initialize the Web5 connection, but also get the DID of the current user, which in a way means that we're authenticating the user. There are different ways you can go about this. You can make this happen on a click of a button, for example, sign up or sign in, or you can do this automatically if it's a single user application like we're building. But because we want this to happen automatically in our application, I'm going to add this to onBeforeMount function in our app. In a regular application, when a user signs in, the first thing you normally do is to make a request either to your database or through an API to see if they have existing to-dos. And we can do that also using Web5 by querying our Web5 SDK, which in turn queries our decentralized web node. So we're going to be loading to-dos. So right now we're searching a query that searches our decentralized web node for every record that matches the schema. This schema could be from anywhere. You can have your own format for storing records. But this is also what we'll use in creating the records so that they match. I also want to sort this by date. So we're going to be doing created date and ascending. If we console.log this, let's see what we get. Since we've created a Web5 instance and a user DID, what we can also do is console.log both the Web5 instance and also console.log our user's DID. Go back here, we have the Web5 instance that is logged right here, and we also have our current DID. So this DID is the public key that's available for identifying the user. For our records, we're not empty. We need to map the returned data to the objects we use in our application. To achieve this, we're going to be looping through each of the records. Then we call the JSON function on the return data property. And after this, we push the value straight into our to-dos array that we initialized up here. Once we start creating to-dos, each object will be added to this variable and displayed in our application. Now that we've seen how we can query records from the DWN, we are going to update our UI to also display this. So I've copied a bunch of code here that I'm going to be pasting and adding to our view. So what does this code do? We are checking to make sure that our to-dos array is empty so that we are able to loop through and then display each individual to-do. We also have an object, we also have a function here that will update later to change the status of the to-do, whether it's complete or incomplete. We are displaying the completed status and also the description of the to-do. The next thing we need to do in an application is figure out how to add to-dos. And we can achieve this with a regular form. So this form is submitted to the add to-do function. We are taking data for the description and also the button. This is what our application looks like right now. So we're able to add to-dos or type it in, but nothing happens yet, right? Because we are also yet to create the function. But our UI has been updated to take the form in, and once we start having new to-dos added, they will show up below here. So let's declare the functions. To add a new to-do, we need to structure the data from our form. So we have our completed property set to false by default, and of course the to-dos description set to the variable that we've created up here and also referenced in the form. The next step would be to pass the data to the DWN. To create a new record in the DWN, we are passing our to-do data to the data property of the create function and also passing additional metadata using the message attribute as well. So we are passing the schema. Remember that this is very essential when we want to search or query our record, as they have to be the same schema. And also we are passing the data format, which is application.json. Any record created to the DWN is signed by the user's DID automatically, and it's also stored in the user's decentralized web node. So this information or this data is specific and unique to the owner of the DID. We also want to be able to update our UI with data that is created. So we are going to use the newly created record to create a new to-do object. And once this is done, we push the to-do object into our to-dos array and update our UI. Let's try that out real quick. You can see one record is returned, and we have our hello world created from the last one. Hi, everybody. We've been able to create and read records from our decentralized web node. The next step is to enable deleting some of these records. And we are going to be using the delete to-do function, where we want to pass the to-do item that we want to delete. To do this, we are going to start with a few dummy variables. Once the to-do item is passed, we are able to loop through all of our existing to-dos record and compare the ID of the to-do item that is passed with the to-do ID in the record in our array. Then the entire to-do object is passed to our deleted to-do variable that we have up here. To delete this record, we want to automatically delete it from our UI using the object that we have. So we're going to splice our to-do object in the UI by removing the to-do item from the index and also removing it from our decentralized web node. With this function, we're able to delete the specific to-do item using the record ID property. Once this is done, all we have to do is update our UI and include a delete button. Ta-da! Delete, delete. Hello. Zoom in. Created, delete. Hi, Web5. Created. Now we've seen how we can create, read, and delete. Now let's learn how we can update. To update this record, we want to be able to set the completed value. And to do this, we use the Todo to-do complete function. We create a couple variables that holds our to-do and updated to-do data. And just like we did for deleting, we loop through to find the to-do item that we want to reference. Once this is found, by comparing the IDs, we update the value in the data and then create a new variable out of it. This new variable is then passed to the decentralized web node to update the record. So the first step is to read the specific record from the decentralized web node. So we have that object. and then we update it by using the record.update function. With this, we're able to update the status and it reflects in our UI. Congratulations, we have successfully developed our first decentralized web app. We're able to authenticate the user to the Web5 SDK by creating a decentralized identifier for them, which in turn also links up to their decentralized web node. So any user that uses this application creates their own to-dos and has it privately stored on their own decentralized web node, and they can choose to do anything with it. So even if they go to another application and the application uses a matching schema or protocol, they are also able to reuse this data across board. If you'd like to follow along building this application, the link to the tutorial is in the description below. I'll see you in the next video.